Okay, welcome along year 11 and potentially even year 10 to homework #1, which is looking at number skills, looking at things like recurring decimals and fraction work. Now, I'm going to go through all of these questions in a bit of detail, and you can self-correct these as you need to. And of course, if you are still stuck, you can come to my interventions. Monday is year 11 further maths, Thursday, year 10 further maths, and Friday is just intervention for year 10 and year 11. Okay, now let's begin with question number 1 up here. I'm still getting used to the software that I'm using on here, so just it might be a little bit it should be okay, should be fine. Okay, question number 1, which is non-calculator, is write down a number that is greater than 2.33 and less than 2.3 recurring. So these numbers, they are a little bit different. The first one, 2.33, is just 2.3 and then 3. That's it. 2.3 recurring. The second one is 2.33 and the 3's. They never end. Okay, so a number basically between these two numbers here, well, I can have 2.331 or I can have 2.332. So my first answer, I'm going to go and put in there 2.33 and then 1. That is between these two numbers here. Okay, and that's 1 mark in the bank. The second one is a fraction with a value between a fifth and a quarter. Now, if you want to sort of compare fractions or find a fraction between them, you want to have a common denominator. Now, 5 and 4 both go into 20, so let's go and multiply the first fraction through by 4, top and bottom, so let's times it through by 4, top and bottom, to give us 4 over 20. And with the second fraction, let's go and times it through by 5 on top and bottom, to give us 5 over 20. Now, the issue here is between 4 and 5, there's no integer, there's no whole number. So I've got to upscale these fractions again, and I can choose how much I upscale by. Let's go and double both of these fractions. So with the first one, let's times the top and the bottom by 2 to give us 8 over 40. And the bottom one, let's double it to give us 10 over 40. Okay, now this is quite nice. Between 8 and 10, I've got the number 9. So 9 over 40 is going to be my answer for this one. So 9 over 40. Now there's infinitely many answers you could put for this. I might have got these to be out of 100 to give me 20 over 100 and 25 over 100. So I could have had 21 to 24 over 100. There's loads of different ways of doing that question. Okay. Good. Number 2 is circle the largest number. Now let's go through and write these as a list so we can compare the numbers nice and easily. The first one, we've got 0.5 recurring, so 0.55555, so on and so forth. The second one, we've just got 0.55. Well, this top number must be bigger than the bottom number because 0.55, after it has a 0, 0, dot, dot, dot. And we can see here, well, these are the same, but 5 is bigger than 0. So it's definitely not going to be this one, not that one. 0.545, 0.545. Again, you can go and put in a 0 over here. Well, these are all the same. This is smaller than these two, so it can't be this one. So this is also smaller. Okay. So it's not this one. Oh, let's undo that. It's not this one. And it's not this one. What about 0.545 recurring? Now this number means 0.545. Now the 4 and the 5 now, they just keep repeating. So 0.545, 45, 45. If we look at the numbers, these are the same. Well, and then this number here, 5 is bigger than 4 straight away. So the biggest number must be the top one. So 0.5 recurring. This is our biggest number, and that is the answer. Nice. Number 3, we've got a question involving surds, root 2 and root 18. Match each expression to its value. One has been done for you. So a squared gives you 2. Let's just double check it makes sense. A squared means root 2. multiplied by root 2. Now this is actually, we haven't been through this explicitly in class, and actually this is kind of like surds, which is like a higher level topic, but just quickly, if you multiply surds together like this, you just write it as one big surd, like this, and you times your two numbers inside the surds. So 2 times 2 gives you 4, and the square root of 4 gives you 2, which is why they've gone for this one. The second one, we've got a plus b, so where a is root 2 and b is root 18, so we've got a is root 2 plus root 18. Now, this is, to get the answer here, you've got to simplify root 18. Okay, now root 18 can be written as 9 multiplied by 2. Okay, so hopefully we agree that 9 times 2 gives you 18. Now from this, we can go and write this as, well, root 9 multiplied by root 2. Root 9 gives you 3, times root 2, you just write it as 3 root 2. So root 18 is the same thing as 3 root 2. This is called simplifying surds. We haven't looked at this yet, but I've just put it in here because it's quite a nice question. I've also got this root 2 that I can bring down here. So I've got root 2 plus 3 root 2. So this means 1 root 2 plus 3 root 2, which will give you 4 root 2, which is going to be the answer down here. Good. AB means A times B, where A is root 2 and B is root 18. So we've got root 2 multiplied by root 18. Now a little bit like the question up here, when you multiply surds, sorry, a surd is just when you have a number in a square root sign that cannot be simple, that cannot be written as an integer. But we saw previously that when you times those together, you get a singular surd. So same thing here, we can write this as one surd. Root 2 times by 18 gives you 36. And of course, root 36 gives you 6. It could also be minus 6, but they've just written it as 6 over here. And then we've got any more? Yeah, we do. We've got this one here, which is b divided by a. So this one we've got b divided by a. So we've got root 18 divided by a, which is root 2. Now when you divide surds, a bit like when you time surds, you write it as one big surd and you divide them. So 18 divided by 2 gives you 9, and root 9 gives you 3. Okay, so this one's going to give you 3. And that's the answers. Okay, this one is not needed. There's only 4 questions, and there's 1, 2, 3, 4, 5, 6 answers. So, oh, we also didn't need 36. So that's fine. Good. Oh, that's it for the first page. Question 4 is looking at a fraction question, which is up here. Let's have a look. So this one here, we've got negative 4 times by negative 7 over 9. Now straight away, I know if I multiply two negatives, my answer must be positive, so it can't be this one, and it can't be this one. Now I'm going to rewrite this, well, negative 4, you know what, because if you times two negatives, it goes to positive, let's just rewrite the whole thing now as positives. 4 is the same thing as 4 over 1. 4 divided by 1 gives you 4, and we're timesing through by 7 over 9. Timesing fractions times the tops. 4 times 7 gives you 28 over 1 times 9, which gives you 9. So 28 over 9 is the answer. Question 5, you've got an identity which is given by this. Now this here is called the difference of two squares, and it's a topic within itself at GCSE. So this, I'm going to make a note of it. This is called, often it's called the difference of two squares, okay? And you often abbreviate it to DOTS. And what this just means is you've got a quadratic, which you can see here, okay? And because you've got two square numbers, x squared and y squared, difference being taken away, you can factorize it to go in this format, x plus y, x minus y, where basically you just square root the first number and you square root the second number and you put it into the brackets. So this question here, without a calculator, to go and square these numbers and do the calculation would take forever. So what you've got to go and recognize here is we can use this up here and say, well, in the two brackets, we're going to square root 193 squared, which will just give you 193. And we're going to add on to it y, which will just be 7. And then it's going to be x, which is 193, take away 7. So what I've done is written this here, which is in the difference of two squares, because you've got a square number, take away a square number, and I've put it into this factorized form over here, which will make things a lot easier now. Because now I've got 193 plus 7, which is 200, and I'm multiplying this through by 193 take away 7, which is 186. Now, without a calculator, different ways you can go through this. I would probably go and say, well, what's 186 times by 100? Okay, just to really work through this, I would say, well, what's 186 times 100? That's going to be 186, and add on 2 zeros, 1, 2. Now you want 200 times it, so you want to go now double this number and say, well, 2 lots of 18600. That's going to give you 37,200, isn't it? So 37,200, and that should be the answer. So just go and highlight it. There we go. Ooh, that's not a very nice color, is it? Bronze. Let's put it in yellow. There we go. And that's your answer. Number B. Question 5b is now to factorize this one below. Now again, it's recognizing that this is in the difference of two squares format. You've got the first number, which is a square number, take away another square number. Okay, so it's going to go into another pair of double brackets. Now the square root of the first number, well, the square root of 100 will give you 10, and the square root of a squared will just leave you with a, so 10a, and it's the same thing at the start of the first and the second bracket, so 10a and 10a, and it's plus and minus always. And then the square root of 81 gives you 9, so 9 here and 9 over here, and the square root of b squared will just give you b, so b and then b over here. So that's your answer, 10a plus 9b, and 10a take away 9b. Good stuff. Question number 6 is a kind of recurring decimal question again, which is to work out 0.47 recurring at 0.312. Circle your answer. Now let's just write out the addition here. So we've got 0.47777, so on and so forth. That's going to keep repeating as 0.312. And we've got an addition going on, so let's go and write it out. Now, you could put in zeros here because 0.312 has a bunch of zeros going after it, and that's going to keep going. Now, the first part, 7 plus 0, would give you 7. That would give you 7. But you've got to remember that that would be a 7 and a 0 here, a 7 and a 0. So that 7 is just going to keep repeating forever. So it's going to have to be, just straight away by looking at it, it's got to be this one, hasn't it? Because the 7 keeps repeating. So I could keep working through this and say that that's going to be 9, that's going to give you 8, and that's going to be 7. Okay, and we can see that this number, 789, 7 recurring, is this one here. So that is the answer for number 6. Okay, question number 7 is to work out this calculation over here. 123 times by 456 is equal to this number here, and write down the value of this. Now it's just spotting that 12.3 is 10 times smaller than this number. You're dividing by 10 to get from 123 to this number, so that's been divided by 10. And similarly, from 456 to 45.6, we are here dividing by 10. Now if you're dividing by 10 and dividing by 10 again, 10 times 10 is 100, so the overall result is to divide the answer by 100. So we're going to go and take 56,088 and divide it by 100. And that's just going to mean your point is going to go back by 1, 2 to 560.88. Is it like a circle your options? No, that's the answer. So 560.88 should be correct. That should be good. And we can move on. Oh, sorry, that was the answer for the previous one, was it? So 560.88, 560.8, and then 8. Good. Question B, we've got this here. 1, 2, 3 times by 4, 5, 6 gives you this here. So the same question as before. Write down the value of this calculation over here. Now, it's using the same numbers again, but it's been rearranged. So let's go and rearrange this here. If for this one, I take 5, 6, 0, 8, 8. Now, if I go and divide both sides by 1, 2, 3, because I'm timesing this by 123, I can divide this by 1, 2, 3 and divide this number by 1, 2, 3. That's going to give me 456. I've just rearranged this equation over here. Now we can see in the question that the first number is the same and the second one up here is 100 times bigger. So to get from the question to what, to get from this to what I've got in the question, okay, it's being divided by 100, right? It's being divided by 100. But the thing is, right, if you go and do 56088 and you divide it by 1.23, okay, if dividing by 123 gave you this, dividing by a smaller number will give you a bigger answer. Okay, so actually it's not going to be 100 times smaller, the answer is going to be 100 times bigger. So it's going to be 45600, 45600. Now just to make sure that idea makes sense, if we just take some numbers like 20 divided by 2, that gives you 10. If you make the bottom number smaller like we did on this one, okay, so make this smaller by 100, let's go 20 divided by 0.02, that would go to 1,000. So even though you're dividing by a smaller number, your answer gets bigger. And it's the same thing on this one. Okay, so 45600 is your answer. Question C, we've got 123 times 456 gives you this again. Work out the value of this one here. Now this one is recognizing that I've not got 123 times by this, I've got 122 times by this number. So I want to take away one lot of 456 from this number. Let's go and work it out. So I've got 5, 6, 0, 8, and then 8 again. And I want to take away 456 from my number. So 8 take away 6 gives me 2. That will give me 3. Borrow 1 there. That will give me 6, 5, and then 5. This should be the answer 55632. There we go. Question 8 is saying estimate. Now, estimation is a really important topic. Whenever you estimate, generally you estimate to one significant figure. Okay. Now that means if you're estimating this number, well, one significant figure is that 1. You're rounding to the nearest 100, so it would be 100 to the power of a half. So 100 to the power of 1 over 2. 6.43, now the first significant figure here is the 6, okay, so that's in the ones column. So this number to the nearest 1 would give you 6, so plus 6 to the power of 0, timesing it through by this here. Again, your first significant figure is the 7, and you round it up to 8, so we're timesing it through by 8 to the power of 2/3. That's really important, right? One significant figure, when you estimate, is something to definitely make a note of. Now, you've got fractional powers here and 0 powers, okay? Now, it's recalling, and I'm going to make a note of this down here, algebraically. If you've got a number raised to 1 over a number, it means you root your number to that power. What on earth does that really mean? For the first one, it just means if you see a fractional power, a half, it means you root your number, which is 100, to the denominator, which is the 2, of that fraction. So you're taking the square root of 100. Now, ordinarily, you wouldn't write the 2 there, but just for this, I'm going to go and write it in there. Now, any number to the power of 0 gives you 1. Okay, that's called the 0 power law. So any number to the power of 0 gives you 1. So 6 to the power of 0 would give you 1. And we're timesing through. Now this one is actually a grade 8 indice question, but it's nothing we can't handle. Now the rule for this is a bit similar to the first one over here. if you have a number and you raise it to a fractional power, you root your number again. So whenever you see a fractional power, you root it, and again you root it to the denominator of the fraction, so that n's going to go here, but then you raise it to the power of the numerator m. So on this one here, it's going to be the root of 8, and it's the square root of 8, and you raise it all to the power. Sorry, I made a mistake there. The denominator is what you root it to, which is the 3. That's going to go here. And you would know that it's not going to be 2 because you can't square root 8 without getting a horrible decimal. And then you put it to the power of the numerator, which is 2. So the square root of 100 gives you 10. Plus 1, and then this part here, well, the cube root of 8 gives you 2, and 2 squared gives you 4, so plus 4 goes in there. So 10 plus 1 plus 4 gives you 15, and that is the answer for number 8. Okay. There we go. Oh, sorry. Right, I've just realised. Really silly mistake there. It's a times here, isn't it? That's a times. I completely misread that. Multiply through by this number, that was 2 squared is 4. Apologies. Now we've got BIDMAS here. Apologies. We've got 1 times 4, which is 4. Add 10, which gives you 14. So the answer is 14. Apologies. I just misread this here as a plus. But that is the answer. That is fine. Nice. Is that question number 8 done? It is. Perfect. Question 9 is a fraction question. Let's have a look. It says this. 1 lap of a racing circuit is 3 3/4 kilometers. Work out the total distance of 4.5 laps. So if that's 1 lap, you want 4.5. You want to times these two fractions together. Okay, so the first thing I would go and do is write out 3 3/4. We're going to times it through by 4.5. Now that's going to get these as improper fractions by converting them. So the first one, that's going to go to 4 times 3, add 3, which is 15/4. So 15/4 multiplied through by 2 times 4 is 8, add 1, gives you 9/2. And now we're timesing these two fractions together. Now, can I make this easy for myself? Probably not. 15 times by 9 is going to give me 135/8. And it's not asking for any particular format, so that's fine. You could write it back as a mixed number, but the question doesn't ask for any particular format, so that's going to be fine as my answer. Question 10 is this. R is the total resistance in an electronic circuit. R is calculated, so this is R down here, by using the formula where R1 is 0.6 and R2 is 1.8. Work out the value of R. Let's just go and put in our numbers. So we've got 1 over R is equal to 1 over R1, which is 0.6, plus 1 over R2, which is 1.8. Now, when I look at this question, I'm just thinking, right, adding fractions together, I really want to have the same denominator. It just makes things a lot easier. And I can recognize here quite quickly that, well, if I times the bottom one here by 3, and times that by 3, we're going to get this to be 1.8, which is really useful. So I've got 1 over R is going to be equal to 1 over 1.8, add 1 over 1.8. And now adding fractions together, 1 plus, it's not very clear, is it? But 1 plus 1 is going to give me 2. So it's going to give me, oh, sorry, what am I doing here? What am I doing? Apologies. This first fraction, 1 times 3 is 3 over 1.8. I'm adding on to 1 over 1.8. Now I can add them properly. 3 plus 1 gives me 4 over 1.8. So 1 over R is equal to 4 over 1.8. So 1 over R is equal to 4 over 1.8. Now this is actually the reciprocal. Okay, so my answer, or to get my answer, I can just go and flip this one over, because this is 1 over. Now I could rearrange this and show you what's going on here. To get the r on the top of this fraction, I'm going to times through by r. That's going to write it out. So I could go and times this by r and times this one by r. So then they're going to cancel out. And that's going to leave me with 1 is equal to 4 over 1.8 times through by r. Now, to get this onto the other side, I can do the opposite of timesing through by 4 over 1.8, which is to divide by 4 over 1.8. And that's just going to have the same result as flipping this over to give me r being equal to 1.8 over 4. And this is my answer. Okay, and again, it doesn't ask for any particular format. It just says work out the value of r. And this is my value of r. And that's it for the homework. Okay, so hopefully that was useful. Oh no, I've got another question, haven't I? Apologies. Question 11. Question 11, let's have a look at this one. Here is a pattern. 1 cubed is 1, 8 cubed gives you 5, 12, 17 cubed gives you this. Okay, and we can see here that if we add together the digits, so the 5 with the 1 and the 2, it gives you 8, 4 plus 9 plus 1 plus 3 gives you 17. Find a number between 25 and 30 that follows this pattern. Now, I probably should have made a note here, but this would be a calculator question, otherwise you'd be here for a long time. But let's just go and try a number. Let's go and try between 25 and 30. If we went and tried 25 cubed, that would give us 15,625. What do they add up to? I'll give you 6, 12, 14, 19, which is not that, so that's not going to work, unfortunately. If I did 26 cubed, using a calculator, that would give me 17,576. Now if I add together the digits, so that would give me 8, 13, 20, 26. Perfect. So that one works. That's good. I need one more. Let's try 27 cubed. That would give me 19,683. If I add together these digits, that would give me 10, 16, 24, 27. Perfect. There we go. So the numbers between 25 and 30 that work here are going to be 26 and 27. Oh, but it's only one. Sorry, 26 or 27. Is there any more? You could work through it. I don't think there are any more, but either 26 or 27 cubed work. If you add together the digits, you make that number. And that is it for the homework. That is it for the homework. So thank you for watching, guys. Hopefully that was useful. Again, if you need any more help with anything, you can attend the interventions after school. But thank you for watching and have a lovely rest of your day. Thank you.